Good morning or afternoon. Today's lesson is about logarithms, or logs for short. Now this is probably something that many of you would have not heard of, so it's going to be a new topic for you, something that typically people can find a little bit confusing. So do make sure you listen carefully to what I say in this lesson, and do make sure you get a really good understanding of what logs are all about, because they are going to be quite important for you. Okay, now they're taught alongside exponential functions, so as you can imagine there is going to be a strong link between logs and exponential functions. So let me just start by talking a little bit about, so imagine you were solving an equation like x squared equals 9. Now if I was looking to solve that, what you want to do is you want to do the inverse operations. Now you know the inverse of squaring something is square rooting something. So you would square root both sides and you would get x equals plus or minus 3. Okay, now let's have a look at an exponential equation. So if I have 2 to the power x equals, say, 5.4, so not a nice number, not something like 8 that you know then x would be 3. How I can solve that in the same way as in this first equation, what I did was I did the inverse of squaring, which is square rooting. Here, what I do is the inverse of raising something, of raising 2 to the power x, is basically taking logs of both sides, or logs to the base 2. So that's really what logs are all about. They are the inverse operation to exponentials. Okay, so here's our sequence of lessons that we're working our way through. We've done the sketching graphs, we've done the differentiation. Last lesson, if you remember, we looked at models of real life situations that used exponential functions. So that was either exponential growth or exponential decay. So today what we're looking at is the relationship between exponentials and logs. So let's go ahead with that. Right. So this is definitely something that you're going to want to write down in your notes. All right, so the inverses of exponential functions are called logarithms, or logs for short. Okay, so here we've got two equivalent expressions. We have got a base number a raised to a power x, and that gives us our answer n. Now the equivalent expression written in terms of logs, this is how we read it. We say log to the base a. This little number down here next to the word log is the base, and that's a. Remember, with your exponential functions, okay, the base is the number that you're raising to the power, and that is going to be the same as the base of the log that's equivalent to it. Okay, so we've got log to the base a of n equals x. Okay. So what I always like to do when I'm thinking about any log function like this here, I always think of as saying, if I've got a log, I would say, what power do I raise a to get n? And whatever that power is, that is the answer for that log expression. So if I had something like, log, we're going to do some of these in a minute. If I had log to the base 10 of 1,000, then what I would be thinking in my head is, what power do I raise 10 to? That's my base, my little number there. What power do I raise 10 to get 1,000? And the answer for that would be 3. Okay. Now, this next slide sort of shows you a way that you can try and remember this, because although your calculators do logs for you, you do need to have a good understanding of what they actually mean. So this is very similar to the example I just spoke about there. Here's my log expression, okay? So remember, the little number here is my base number, so that's 10, okay? How I would think about this in my head is I would say, what power do I raise 10 to get 100. And hopefully you think, oh, that's 2. So the equivalent exponential form is 10 to the power 2 equals 100. Now, if you grab your calculator, calculators do logs for you. Find yourself the log button. It's just below the integration button that we were using before. So if you type that and you type in 10 as your little base number down at the bottom, and you type in 100 and you press equals, you will get 2. So you've always got your calculator to remind you if you kind of forget what does the little number mean, what does the big number mean, you can use it to help. Okay, right, well let's see if we've kind of understood that. So what we're going to do here is we've got 3 expressions written in exponential form, and I'm going to write those as equivalent logs. And we've got 2 ones written here in log form, and I'm going to write those as the equivalent exponentials. So let's start with 3 to the power 2 equals 9, which you all know is true. So I'm going to write the word log. Now, logs are always taken to a certain base, and the base is going to be the number that you're raising to the power. So that's going to be log to the base 3 of 9. Okay, and that equals 2. So remember, when I'm looking at this log expression here, I'm saying what power do I raise 3 to get 9? And the answer is 2. And you can quite happily, if you want to, type this into your calculator. Okay, if you type in log to the base 3 of 9, it will tell you 2. Let's do this next one. So log. The base, remember, the little number here is always the thing, it always does that, is always the thing that you are raising to the power. So that's log to the base 2, okay, of 128, and that equals 7. Okay, so again, look at my log expression here. What power do I raise 2 to get 128? And the answer is 7. Again, check it in your calculator. Let's do the final one of this form. Log, the base number is 64. Okay, 8 is my answer in my exponential form. And here I'm saying, what power do I raise 64 to get 8? And the answer is, well, I square root it, but as a power, that's going to be a half. Okay, right, let's do these in equivalent form then. If I've got this, then the base is going to be the base of the log, so that's 3. The answer is the power I'm raising it to, so that's 4. And that gives me 81. So remember your log. What power do I raise 3 to get 81? And the answer is 4. Okay, let's do this final one. A little bit trickier numbers. Remember, my base is going to be 2. The answer is the power 2 to the minus 3. We know our negative powers are 1 over, so that's going to be 1 over 2 cubed, well, that's going to be 1 over 8. Okay, so hopefully that's given you a really good idea of what the link is between your exponentials and your logs. So really do make sure, I know you can use your calculator to work them out, but really do make sure you understand the equivalence between these and what is actually going on with these log expressions. Okay, so without using a calculator, find the value of. Now we can use our calculator to check. Okay, so here's where the thing that I say in my head to myself. I say, what power do I raise 3 to? So 3 to a certain power is 81. Okay, so what power do I raise 3 to get 81? The answer is 4. And you can check that in your calculator. Let's do the next one. What power do I raise 4 to get 0.25? Might be easier if we write 0.25 as a fraction, which is 1/4. Okay, if that's written as a fraction, 1/4. What power of 4 gives you 1/4? That's going to be -1. So you can see logs have values positive and negative. Okay, let's do this last one. 0.5 to the power what gives me 4. Now it's a little bit more tricky, especially when that's written as a decimal, but what I suggest is whenever you have decimals to do with logs, write it as a fraction first. And then, what power do I raise a half to get 4? Well, this isn't a fraction, so what I'm going to have to do is I'm going to have a negative power so that I make that a half into a 2. So if it was -1, it would be 2. It needs to be 4, so it's going to be -2. So you think about it, if I do half to the -2, then I'm going to do 1 over that, and I'm going to square it, so that's right. Okay, let's have a look at this. Right, so this is saying, what power do I raise 2 to get 2? Well, it's going to be 1. So this is quite an important thing for you to remember. If you've got any log to the base a, if I have log to the base a of a itself, it doesn't actually matter what those numbers are, but log to the base a of a itself is always going to be 1. So that's a useful thing for you to make note of and for you to remember. Okay, this one here, a little bit different. We haven't got numbers here, but actually it's easier when it's written in this form, because back to my definition of logs, what power do I raise a to get a to the 5? Well, easy, 5. The only thing obviously with something like that is you can't put your calculator, you can't put that into your calculator. So that's where you've got to have a really good understanding of what logs are all about. So let's do this last one here. This is saying what the power that I raise 3 to get x minus 1 is going to be 4. Okay, so 3 to the power 4 is x minus 1. Then I'm going to need to go and solve that. So 3 to the power 4 is going to be 81. Oops, x minus 1. So that means x is equal to 81 plus 1, which is 82. Okay, so just a little bit of solving there. Again, your calculator wouldn't do that one for you. So this is where you've really got to understand what is going on with these log functions or what they mean. So it's what power do I raise the base to, the little number, to get the answer, and then that's the right hand side there. Okay, right. Now the ones like this, log to the base 3 of 40, if I was to do the same sort of method that I was doing on the previous ones, I'm saying what power do I raise 3 to get 40? Well, we can probably make a bit of a guess because we know that 3 cubed is 27, and we know that 3 to the 4 is going to be 81. So it's definitely between those, probably closer to that one. So we reckon 3 point something, you know, less than 3.5. So let's put it in our calculator. So all of you type it in, log to the base 3 of 40, press equals, and it tells us, asks us for 3 decimal places, 3.358. So it was as we expected. We knew it was going to be 3 point something. We knew it was going to be less than 3.5. Okay, although you have got to be a little bit careful with how logarithmic graphs grow. All right, but we knew it was going to roughly be between those two things. Okay, let's have a look at this one. Log to the base e of 8. So what that is saying is e to the power what equals 8. Okay, well, e to the power 1. Okay, remember on your calculator how you can press the E button. So E on itself is 2.718. Almost 3, I guess. So if I was to square that, okay, E squared, that's about 7 point something. Okay, So we know it's probably going to be a little bit more than that, so it's going to be 2 point something. But again, pop it in your calculator. Okay, so log to the base. Remember where you get your E button for? It's basically alpha and then the times 10 to the x. So log to the base E of 8 and press equals. Okay, and we get 2.079. Now, we've seen that within those modelling functions that we were doing last lesson, we've seen that e to the power something is incredibly useful to model real life situations to do with exponential growth and decay, like population growth, radioactive decay, purely because what that means is then that the rate of change is proportional to the value of that actual thing that you're looking at is changing. Now, because it is so special, this log to the base e is actually given its own name, and it's called ln. So if you have a look on your calculator, just to the right of the log to the base something something button is a button that says ln, or ln is how you say it. So if you use that one and you type in ln of 8, what you'll notice is you get exactly the same answer as what we've written down here. So we never use log to the base e, we always call that ln, ln. So that's something useful to remember. Right, let's do this last one then. Okay, so this is saying what power do I raise 10 to get 75? Okay, well, we can work out roughly what it's going to be, because 10 to the 1 is 10 and 10 squared is 100. So we know it's going to be 1 point something. Let's type it in our calculator to check. Log, type in 10, type in 75, and you get 1 point, which they want 3 decimal places, 875. Okay, so you can use your calculator to type them in to work out exact values of logs, but I can't emphasize enough the importance of understanding what that means. Okay, so I should, for you, be able to write down things like log to the base 3 of 27, and without you typing that into your calculator, you should know that I'm saying what power do I raise 3 to get 27, so you should all be able to tell me that that's 3. And similarly, you know, if I said log to the base 2 of 16, what power do I raise 2 to get 16? Okay, and that answer is 4. You should be able to tell me that. And also something like log to the base b of b to the power 6, you should immediately be able to tell me, well, that's 6, because you can't put something like that in your calculator. Okay, so hopefully you've got a really good understanding of that. So it's really over to you now. Exercise 14D, basically all of the questions. There's quite a few of them, but they are quite short and sweet questions like those. Do write out the question first. Do make sure you really fully understand the links between exponentials and logs. If you don't, maybe watch this video again to make sure you really have got a good grasp for it, because then the next few lessons we're going to be looking at further details of log laws, okay, and then on to solving equations that involve logs. So it's really important that you do understand this. Okay, well, thank you for listening and good luck with that.